In this lesson, you'll learn how to apply iteration in your program, how to combine it with sequencing and selection, and how to visualize it all with a flowchart. It's all coming together, right? We briefly covered the topic of iteration. Actually, I don't know that it was brief. We actually covered iteration pretty well in the previous lesson. And you had the opportunity to experiment with the forever block, creating an infinite loop, which is often very useful. A more common scenario is repeating an action for a specific number of times. So when the number is obviously less than something infinite. Scratch makes this simple with repeat blocks. We can use a repeat to make drawing shapes a lot easier. And you can see a script to draw a square on the right. In both scenarios, this type of control flow is a loop because the flow cycles back around to a point at which the program has already executed an instruction. And in the case of the forever loop, the cycling continues as long as the program is executing. And in the case of a repeat block, the loop is only going to execute the number of times specified by the parameter. In this case on the screen, you can see that it's 4. So the question would be, what would happen if instead of repeat for, if this was a forever block right here, as it is over here? So this is forever and it's going to continue infinitely, indefinitely. So if you can picture, it just would be continuously drawing a square forever and ever and ever. In this exercise, you'll get a chance to try it out. You'll be able to develop algorithms that will draw a square, perhaps a triangle, a pentagon, hexagon, octagon, and a circle, and even a 5-sided star. Your algorithm might be a little bit different for that one, but we'll wait and see. Enjoy trying it out. There's another Scratch block that lets us repeat things. It's called the repeat until block. So just like repeat, it's going to do everything that comes inside this loop, this kind of C shape or alligator mouth or whatever you want to think of it as, a certain number of times. So just like the if block, it is still dependent on a condition. All right, on having something evaluate to true. In the example you see here, before it starts the loop every time, it's going to check to see if the condition x is greater than 5 is true. And if the condition is true, it's not going to repeat again. The repeat until block can be really helpful to track what the value of the variable x is at any point in the iteration to help us understand how this new piece works. And remember that when you create a variable in Scratch, you have the option to place a check mark. Remember, we created a variable and then you have a little oval to show that it's holding the value of that variable. And you can put a check mark and that value will be displayed on the screen. So that's what you want to do when you run this. And what we can do, we look at what the value of x is before the loop. Okay, and we can see right here that x has been assigned a value of 0. Then we go through the loop once. All right, so at the top of the loop, it's coming in with a value of 0, but once the loop has executed, it now has a value of 1, okay, because we told it to change x by 1. So up here, we know that x is now 1. All right, then coming in at the top of the loop, it still has a value of 1. But by the end of the loop, it now has a value of 2. All right, and so on and so forth. So each iteration, coming into the iteration, x has a certain value, but coming out of the iteration, it has a new value each time. All right, and it's going to continue until the value of x becomes greater than 5. So just being 5 is not enough to make it come out of the loop. It has to actually exceed 5, and right here it does. So once it turns to 6, this loop would close out. In this section, in this try it out, you'll make a diagram just like the one that we just looked at to track what would happen in this more complicated repeat until code. So the next comparison we'll make is between the repeat until structure, so repeating until a condition is met, versus the nested forever if set of blocks. All right, so we can see similarities. We can see that they both have the same shape. They both take a Boolean. All right, so what makes them different? They're both going to repeat. The thing that makes them different is that the repeat until will terminate, okay? Or we're assuming that it's going to terminate, okay? Because the condition will be met and then we will go on and there will be instructions below here telling what to do next. However, over on this side, we can see that the forever block eliminates the ability for us to add another block underneath this one. All right, so we have a condition that we're checking for forever. We're constantly checking for this condition. And if the condition is met, then whatever instruction is in here will execute. And then we'll move on. All right, so there's no termination. All right, there's no way to terminate, to exit out of this loop. It's just always checking. Now, we know about loops. And so now it seems pretty reasonable that we could apply this understanding to changing the speed of a song. It can be much easier than maybe providing a sequence of instructions telling when and by how much to change it. Maybe we could use loops to help this, and maybe a variable as well. So you're going to have the opportunity to work with loops and iteration and repeats by actually changing the tempo with music. You'll need a variable called tempo. You'll have to go to the extensions and add the music extension if you don't already have that in your tabs. And then this is just a quick version of what the program might look like. So let's take a look. Let's go in and let's give you a chance to try it out. Well, hopefully you enjoyed that little experiment, just looking at how repetition and iteration can really change things in your program. And you're going to actually now take a look at a program that actually uses not just iteration, but all three of the logical algorithmic structures that we have talked about so far, namely sequencing, selection, and iteration. And you'll get a chance to take a look at an exercise, and then you'll get actually a chance to make your own exercise. All right, so now you know all about sequence, selection, iteration. We've looked at nested, if then else. We've learned about variables and using Boolean operators to compare and create conditions. So let's take a look at a program that puts all of that together, because that's something that you will end up doing. You can probably see on my screen that the cat is going to ask the user if they would like to play a game. If the answer ends up being yes, then we will go to this part of the script right here, right? So here is what will happen if the user does say yes. Okay, all of that stuff right there will happen. However, if they type anything other than yes, I'm going to jump all the way down to here. So I will branch off in a completely different direction. That's what that if then else does. And the game will actually not ever start, right? So we give the user that option. All right, but if the game does start, if the user does want to play a game with us, oh, here I threw in a little random operator there as well. So we are going to have a variable called magic number, and it's going to be randomly chosen right here. It's going to be between 1 and 10, and that is inclusive. It could include 1, it could include 10. All right, we're going to give our user 3 chances to guess the magic number. Obviously, if we didn't limit the number of chances, they would have to guess it in 10 unless they were just really terrible at playing this game. But to make it a little more challenging and just so that everybody doesn't win every time, we're going to limit the amount of guesses that they have. We only give them 3 chances. All right, so we're going to repeat this 3 times. So we're going to iterate through what's inside this loop 3 times. All right, well within here, we're going to ask, what is the magic number? We're going to ask a new question. And then we've got a new variable. We want to track how many guesses they've used. So we are going to take guesses and increment it by 1. Then we come to a decision. All right, so if what the user types in is equal to the randomly chosen magic number, then you win. All right, and then everything just stops. Nothing else is going to happen. If you haven't played around with this, it can be pretty useful. It's almost like a return statement in a function. But if they get it wrong, that's the else, then we're going to check and see, listen, how many times have you gotten this wrong? Because if you're on guess number 3, you're done. All right, and that's what goes on right here. If guess number equals 3, then we're just going to say, oh, too bad, you're out of guesses, better luck next time. And of course, we could go back and ask if they want to play again, and then the whole thing could repeat. But that's a little bit more than we need to do. But if they still have guesses left, if guess number has not reached 3, then we'll give them a little encouragement. Try again, all right, for 2 seconds. All right, so let's see how all of this works. So I'm going to hit my green flag. That's my event. It's going to get everything started. There we go. Hello. Would you like to play a game? All right. Now, again, anything other than the word yes. Like, for example, the number 7. Yeah. It just causes the program to finish out. That's it. It didn't get what it was looking for. Nothing happened. Okay? But this time, I'll play a little more nicely. I'll play along. Yes. Cat, I do want to play. Okay, good. I've got 3 chances. And interestingly, over here, it's not doing apostrophes today. You can see the breakout code for apostrophes. That's interesting. Every now and then Scratch does strange things. So that's the breakout code for apostrophes. It's just not wanting to display that actual apostrophe right now. What's the magic number? All right. Well, remember how you can show variables? I still have check marks over here. And so I'm kind of cheating right now. So let me just go ahead and be a cheater. And I'm going to put in number 7. Look at me, I'm a good guesser, and I won. So that proves that this part right here works. If the magic number is equal to the guess, then you get told you won and you're done. All right, but this time, I won't cheat. Okay, so yes, I'm playing along, and I'm not cheating. All right, I'm going to pretend that I can't tell what the magic number is, and I'm going to guess 4. Ooh, darn, that was wrong. Let me guess again. I'm going to guess 6. Oh, no, I only have 1 guess left. I hope this is right. I'm going to guess W. Ooh, that was wrong. And I'm out of guesses, and better luck next time. All right, and again, it's just not wanting to deal with apostrophes today. That's why it looked a little strange. So that just shows you can combine a lot of things in here. So let's go back and pick this apart. What exactly did we see? All right, well, right here, I see a sequence of instructions to get started. So no matter what happens, there are certain things that have to happen in the right order. I can't say, would you like to play a game before I say hello? That would be a little weird. All right, so there's my sequencing. And of course, there are several other sequences of instructions in here as well that have to happen in a particular order. What about selection? Well, There are plenty of decisions to be made. I have a lot of if-else statements. I've got actually 1, 2, 3 nested if-else statements here. So that's my selection. So I'm saying if a condition is true, and a condition is going to be a hexagon, that Boolean value, true or false. If a certain condition is true, I'll do one thing, but if it's not, I'll do something else. And finally, iteration. Right here, this is our extra challenge. We don't want to just let them keep guessing time after time, because by the time they've used up 10 guesses, they will have guessed again, unless they're just really, really bad at it. But that repetition, that iteration, limiting it to 3, actually makes the game just a little bit more challenging. All right, so that's just an example, and surely you'll come up with something much more exciting than guessing. Hopefully, when you want a user to play your game, just remember to hide your variables. You could maybe keep the guess number on that, but you really wouldn't want to have your your magic number showing. Anyways, you'll come up with something great, and you'll have fun doing it and have fun showing your classmates and your teacher what you did.